CC family.
Hi.
Welcome to Cycle 1, Week 14, Science. I'm Miss Madeline, the ABC Darien tutor, and I have my helpers, Zoe, Eden, and Summer. Hi. We miss everyone so much, and we're counting down the days until we can be together again. For today, we're continuing on with our research of earth science. We're going to be using a little bit of geology, mineralogy, and some help from physics to learn more about rocks and minerals. Thank you. Just a quick refresh, our scientific method. The scientific method is question, research, hypothesis, materials, experiment, analysis, and conclusion. Our experiments for today are from our Van Cleves experiment guide, number 125, spoon pen, and 126, Stampler. We ready to get started?
Yeah.
Our first experiment is going to teach us how to identify different kinds of minerals. We learned last week what minerals are and where they're found. Today, we're going to identify them. That means give them names. Now, many scientists have come before us, and they've already named the minerals that we know of today in Earth's soil. So we're just gonna have to find out what they're called. To do this, we're gonna be doing something called a mineral streak test. Do you guys have any questions about identifying minerals or about streak tests?
What's a
What's your
streak
question?
test?
What's a streak test?
What will happen?
What will happen? My question is, it's a test, right? Am I graded? Does it hurt? I don't know. We'll find out.
It's not graded. How?
All right. So our next step is research. Now this week in our new grammar, we've learned about 3 types of rocks. 3 types of rocks are metamorphic, sedimentary, and igneous rocks. And we have some examples to show you today. Some examples of igneous rocks are things like obsidian, granite, and pumice. Some sedimentary rocks are things like sandstone and limestone, and calcite. An example of metamorphic rock would be something like marble or slate. All right, we're gonna start off our mineral streak experiment a little bit easy by showing you a mineral that we use all the time in school. Chalk. Has anybody ever used chalk before?
Yes.
Chalk. Chalk is a mineral and it's made from something called calcite. Now I can streak my chalk any way I like. I use it to do my math. I use it to write my ABCs, or even to draw a funny picture. We use other minerals every day and do streak tests that we didn't even know. For example, we use the graphite in our pencils to write on our paper. Can you guys go ahead and show me an example of a streak test on your paper? Now, graphite is a mineral that is very, very soft, and so it can be streaked across something as light and as thin as paper. Very good. All right, go ahead and show me your streak tests.
I'm not gonna.
Oh, okay. Wow.
Listen quickly. Done.
Yay! Now we do streak tests every day, but for this experiment, we're going to be turning our spoon into a pen. I'm going to go ahead and hand out some spoons. Go ahead and turn your papers over to a blank side. Can you use these spoons to draw on your paper? Go ahead and give it a try. I'm sorry. Go ahead and streak that spoon across your paper.
Nope.
What happened?
You can't use it.
We can't do it. The minerals inside of our spoon are too hard and they won't streak the paper properly. We have to use a different material. We're going to be using tile or a kind of pottery to streak our minerals today. I'm going to go ahead and pass out these. Now, if you don't have a tile at home or pottery at home for you to use a streak test, you can use something like an old kitchen tile. You can even just go outside and use the sidewalk and your minerals will scrape right across the sidewalk. But for today, we are going to be using tile. All right, now take your spoon and go ahead and streak. Oh, actually, wait, hold up. We forgot something. Our hypothesis. What do we think is going to happen?
I think if you scrape it on here, it might make something happen.
Oh, something might happen. That's possible. What do you think is going to happen?
What I think is gonna
Don't
happen.
do it yet.
What I think is gonna happen. Actually, no. Just made a whiskey. It's that it is. Oh my
don't have to know. The good thing about the hypothesis is it's our best guess. We either might be really confident or we might have no idea what could happen. So go ahead and hold on to your pottery tile. Take your spoon and scrape the spoon across the tile and see what happens. Do you see what happened to mine? I turned my spoon into a pen and I can draw. I can write my name. I can draw a shape. I can draw a star or a heart. I turned my spoon into a pen. Go ahead and try mine. Oh, try turning your tile over or using a different tile. And use my spoon if you like. You have to go really hard to streak it. All right. Good job. Yeah, grind it really good. Now can you show us what they look like?
Wait, I'm still drawing something.
All right, go ahead and hold it up. Yeah, all of our streaks are dark gray, almost black color. I could use it to write. Now, why does this happen? What are our spoons made of? Do you guys know?
Metal.
Metal. Spoons, this particular kind of spoon today we use, are made of stainless steel. Stainless steel is a combination of minerals called an alloy. It is mixed iron, carbon, chromium, and even sometimes the metal nickel is in our spoons. Please don't do that. Thank you. Let's treat our tools with respect today. Go ahead and pass up your mineral streak test and your spoon. Now, oh, thank you. Yeah. Now, something to note about our stainless steel spoons. That's okay. They're very hard. They're very hard. So they can streak across that tile. Now the iron in our spoon is much harder than the graphite, so the spoon did not streak the paper, and that's okay. So there are 8 different kinds of tests that scientists use to determine what the mineral is. The first one is called hardness. Not that kind of hard. It tells you how hard it is, if it can actually scratch a hole in something. That's what they mean by hard. Then there's an example called luster. Luster is, how does the mineral react in light? Does it reflect? Is it glittery? Can you see through it? That's what luster is. Another thing we use is the color. What color is our mineral? I see minerals on the table now that are red, black, brown, green, so many different colors. Yeah, purple, great. If we can't determine with those tests, we'll do more invasive tests. We'll do things like tenacity tests, where we do chemical reactions. We'll find their specific gravity, and we'll do a streak test like we did today. Now, some examples you can see on our chart behind us are some gemstones. Things like amethyst, aquamarine, rubies, and sapphires. They come in so many different colors. But when you streak that mineral across that pottery tile, it comes out white, no matter what the color of the gem is. And that's because the mineral is a very similar component in each of those gemstones. They're the same type of mineral, but they come in different colors. Their streak is white. Yes?
And again, if you scrape it up across paper, a hole will show.
A hole would show because it's so hard. Gemstones are very hard. In fact, we wouldn't be able to do a streak test with something as clear as a diamond. A diamond is one of the hardest substances, and it would actually grind a hole through our streak test, and it would have no color at all. Okay, hold your questions for just a minute. So things like azurite, they streak blue. Things like stinky old sulfur will streak a yellowish green. There are so many different colors that we can detect each different kind of mineral. Now that we know what our minerals are, we can use them properly.
Oh, no, this is gonna be awesome.
So some memory work we did this week was about gold in Ghana. We learned that the people of Ghana, they discovered gold deep down underground, and they harvested that gold to trade for many things through Europe and through Africa. So I'm going to show you something really special that we have here. We have our very own gold. Gold. Now when you streak gold across a pottery tile, it comes out this beautiful, shiny yellow color. It is amazing. And when you see that gold powder, it just looks so good. I'm going to show you my gold today. When I streak my gold, you're going to see. Oh no! My gold streaked black. What a fool I am. This is something called fool's gold. Many miners throughout history have discovered these beautiful golden nuggets. You can go ahead and streak it on your own tile. But it turns out they were not gold at all. A simple streak test can help identify that it's pyrite and not gold.
It's easier to write with, isn't it?
Very good. So we're going to use our Bible in conclusion in John 13:35. Quietly, please.
Leave it.
A new commandment I give unto you, that ye love one another as I have loved you, that ye also love one another. By this shall all men know that ye are my disciples, if ye have love to one another. The Bible is telling us that we can demonstrate God's love, the love of Jesus, by the mark that we make on each other. So while we're continuing on in our science experiments and with the rest of CC learning for today, try to remember, what mark are you making on the people around you? How can we identify you by your actions and your love? Thank you. All right, go ahead and pass up your materials. We're going to go on to the second experiment. Thank you. Very good. Okay. On our next experiment, 126 sampler, we're going to talk about what is happening underneath our feet right now. We're going to talk about something called core sampling, and we're going to demonstrate core sampling. So to go back over our scientific method, what questions do we have about core sampling and what's underneath our feet?
The thing underneath our feet is people.
People, maybe.
People. Or
Do you guys have any questions about what's underground?
Ooh, maybe like solid rock. So then like it's hot. So then like if people stomp, like it won't break.
Yeah.
It's hard rock.
Hard rock. Very good. Those are some great questions. What's underneath our feet? Is it hard rock? Are there people under there? Let's take a look.
People are not.
Some of the research we've done in the past is talking about what's in the middle of the earth. Can you go ahead and hold up the picture of the layers of the earth? Last week in our CC Science memory work, we talked about what is the geosphere. We learned about the geosphere, core mantle crust, core mantle crust. Ready? Yeah. Core mantle crust, core mantle crust, atmosphere, biosphere, hydrosphere. Yeah. So we know a little bit about what's underneath us, but I bet you didn't know that the crust is only 21 miles deep. That's the soil beneath our feet. It is only 21 miles deep. Have you guys ever dug a hole before? Do you like to dig holes in the dirt?
Not really.
What's the deepest hole you've ever dug? The deepest holes that scientists have ever dug were only 7.5 miles deep. That's still really far, and we still haven't dug all the way down through the crust. The mantle is even deeper. It is 1,774 miles, and the core is even bigger than that.
And it probably get very hot. And you probably might fall into it.
For today's experiment, we're going to talk about a core sample, and we're going to make our own using Play-Doh. I'm going to hand out a little bit of each. Now what we're going to do is we're going to take the Play-Doh and we're going to smush it down, but don't make it so thin that it's like a piece of paper. We still want some thickness. Go ahead and mush it down. Yellow. We're going to mush down some orange. We're going to mush down some orange. Here you go. And finally, oh, be careful. Finally, some brown. Here we go. Brown. When you think you've got them mushed down pretty good,
But not too much.
but not too much, we're going to go ahead and put them together. Any order that you like.
Is this looks good?
I think that looks great. Once we have them pushed together, you can make it a thickness, maybe about that much. You kind of want to make a nice thick pancake.
Like this?
That looks great.
Pancake.
Now try to mush it together a little bit. Pancake.
Pancake.
Finally, our third color. Mush it down like a thick pancake. Now we're going to take all three of our pancakes and we're going to squish them together. You want it to be maybe about 1 inch thick. This looks like a good pancake to me.
It looks very colorful.
There we go. All right, go ahead and put it in front of you. When you have it nice and squished together, yeah, very good.
You like Mr. Sabal.
We're going to go ahead and use a straw to make our own core sample. To do that, we're going to push down this cylindrical tube We're going to push it down flat. And we're going to push it down all the way to the middle. All the way down. Then I'm going to hold on to the clay and pull up. And I've taken my very own core sample. Go ahead and give it a try. Now for the Play-Doh, we can use very small straws. You can also do this experiment with things like modeling clay. With modeling clay, you're going to want to use a much thicker straw. Make sure you're putting equal force down on the straw.
Ta-da!
Very good. Now, this is why we're using physics today, because putting equal force pushed down directly through a hollow tube is going to push the clay and the minerals directly upward with equal force. And taking a perfect sample, it doesn't change the composition of what is inside.
I think my brown.
Now don't pull it out yet. We're going to use scissors to cut. We're going to cut open our core sample.
I have two core samples. Me too.
Like this.
Yeah. Can I have a really big one?
Yeah, just a minute.
Wait, I already have a huge one. Ta-da!
Good job.
Yeah.
There we go.
Don't destroy your samples. Can I have the scissors? No,
You can use the scissors. You can use the scissors. So now that I've taken out my core sample, I can study it. I can see how much of each color do I have. Do I have more blue than red? Do I have more pink than blue? What is my core sample made of? Now, in real life, scientists don't use a straw. They would use a huge machine that takes a metal cylinder. It is very hard and it goes very deep into the earth. Some core samples can be as deep as about 3 miles down. Now, you might need a grown-up's help with the scissors. It can be difficult. So raise your hand if you need some help.
Me.
Good job.
Yeah.
Now, the scientists can't cut open that metal cylinder. In real life, they use a wild machine that almost acts as a plunger where it sucks the core sample right out of the cylinder, and they store it in the laboratory to do many different kinds of tests. All right, now that we've seen our core sampling, let's talk about why scientists do that.
I can't even blow it.
What kind of scientists use core samples? Well, the truth is many different scientists use core samples. We're talking about rocks today, so we know that geologists use core samples to look at what kinds of minerals are deep down in different parts of the earth. We know that people, they study things like the watershed, and they look outside of farms or in farms to see what kinds of contamination are happening to our agricultural industry.
I think we did it too much.
No problem. Here we go.
Can we have a Play-Doh?
No. No, we might need the Play-Doh again for another experiment, so hold on to your Play-Doh.
Please help. And I can take them apart.
Here's your core sample. Thank you.
Mine's stuck in a hole.
Okay, well we're gonna cut it. Let me see. Okay. Very good.
It's a little stuck.
We know that creation scientists use core sampling to look back into the earth and find out any evidence of catastrophic floods in the time of Noah. We even know that climate scientists, they use core samples in different ways. They do core samples of things like trees. They do core samples of even ice deep down in the glaciers. They can search for things. What kinds of minerals are underneath that shelf of ice? We also know that even architects use core sampling to determine if the minerals underneath the ground at their site of building is strong enough to hold things like a building or a bridge. So core sampling is very important.
Our core sample is circle.
Very good. Take a good look at your core sampling.
One brown.
What's it made out of? How many different layers do you see? Which layer is bigger? These are all questions that we can ask by looking at our core
Brown
samples.
is the biggest.
Thanks for joining me today. We'll see you next week. Bye.
Bye. Hi.